Bonsoir tout le monde. Donc c'est un meet-up assez particulier puisqu'il a été fait en moins de 2 heures. On a trouvé une salle en 2 heures. Donc, si vous êtes dans la salle et que vous avez une salle comme celle-ci, donc on a un speaker qui a envie de venir nous parler. N'hésitez pas à revenir vers nous très vite, de façon à ce qu'on puisse avoir des hors-séries, plus de hors-séries que d'habitude. Bien sûr, on a nos meet-up réguliers. Le prochain ne sera pas aux alentours du 14 décembre, mais plutôt le 21 décembre, puisque bien sûr, c'est la nuit la plus longue, donc il faut bien commencer la nuit d'une bonne façon. Et puis, on n'a pas encore de présentation, donc si vous avez envie de présenter, n'hésitez pas. Donc, c'est le 4e meet-up hors série de la saison. C'est assez rare d'en avoir aussi autant d'un coup aussi vite dans l'année. On espère en avoir plus, en particulier si vous connaissez des gens qui ont envie de parler de façon un peu plus grande sur un sujet très précis en machine learning et qui passent à Paris, qui sont là pour aider vous. Je pense que maintenant on peut commencer à avoir la capacité de pouvoir amener une cinquantaine de personnes. Donc, n'hésitez pas à revenir vers Franck moi-même pour le faire. Ce soir, c'est Chris qui va nous parler du Deeplearning4j. Chris parle tout à fait français. Je crois qu'il préfère s'exprimer en anglais. Qui a un problème avec le fait qu'il s'exprime en anglais? Personne, là, c'est. Voilà. Donc, alors, la présentation va être en anglais. Et les slides vont être en anglais. Donc, is that okay if it goes by speaking English and getting the slides in English as well? Yes. Okay, speaking English. Okay. So generally, we don't do that. Generally, most of the speakers speak French, but it's not a requirement by any means. We generally ask people to put their slides in English so that whoever is speaking actually gets to have the subtitles there on the slides in English. So most of the people can actually speak the 2 languages. We try to make it more French because a lot of French people here can basically think much more deeply in French than in English. But otherwise, you can ask your questions in French and in English. It doesn't really matter. Chris will be able to answer both languages. You have the 3rd language? Okay. And speak Spanish as well. So if you have a question in Spanish, you might go ahead with that. So given that, just to say what I just said in French, the regular meetup, the next one, is going to be around December 14th, but more like December 21st. Mostly because it's going to be the longest night of the year, so we better start with something interesting, like meetup. If you have any presentations, please come back to Frank and I to the form, and we'll get you on the scale. Chris, right now we are on streaming, so there is a video of this. I'm pretty sure that's Chris is going to be speaking very loudly, so that the microphone can pick up on this. We also have the presentation, Chris's presentation on relaunch, actually. So the presentation and the video should be on relaunch, and they will eventually be on the archive section of the meetup.
Thanks, York. Guys, there's some free chairs up here if you don't want to stand for the whole presentation. Yeah, so hi. My name is Chris Nicholson, as Igor said. I'm the CEO and one of the co-founders of a startup called Skymind. Skymind is a 2.5-year-old company. We employ about 15 people, 10 of whom are deep learning engineers. We came through Y Combinator, and our purpose in life is to bring deep learning to large organizations. So the subject of my talk tonight, after I tell you a little bit about what we built, is to dig into some of the problems that we run into deploying deep learning to production. And I'll try to tell you what we've done to solve some of those problems. So we're an open source company. We built a framework called Deeplearning4j. The J is for Java. Java, as you may know, is one of the largest languages in the world. And Deeplearning4j is one of the largest deep learning tools in the world. It's not the largest. TensorFlow is the largest. Caffe is the second largest. And most tools out there focus on the Python community. Quick question: how many of you here work in Python programming? A lot of you. How many of you here work or program in Java? Great. Okay. And how many of you here use Deeplearning4j already? Anybody? Oh man, all right, I've got a lot of work to do. The Deeplearning4j is just one of several open source libraries we've built for the JVM ecosystem, and we support it like Cloudera supports Hadoop. That's kind of what we do as a company. So this, I hope you can read this. The parts in gray and white are what we built, and the parts in orange are kind of what we work with, right? So Deeplearning4j would be the equivalent of Keras or TensorFlow, right? ND4j, which stands for n-dimensional arrays for Java, is a tensor library. It's like NumPy, but for the JVM, we built that. DataVec would be the ETL, right? So if you work with Hadoop, this would be Scoop, right? It's data pre-processing and cleaning. And then we go down lower than that. So one of our engineers built something called Java CPP. It stands for Java C++. It's the bridge between the two languages. It hooks Java into lower level faster code. And that's important, as you know, because deep learning is computationally intensive, right? So neural nets take a long time to train, right? You either need a lot of time or a lot of hardware, and sometimes both. How's everybody doing? Am I speaking too fast, too low? Everybody understands? Cool. Okay, great. So you know, when we go into companies, a lot of them aren't sure how to approach AI. As a lot of you probably know, on its simplest level, AI is just a bunch of math and code in a black box in the middle, and the data goes in, and the decisions about the data come out, right? AI is a decision-making layer, generally, that's applied to data. So the companies who may succeed building a deep learning solution someday need to know the decisions they care about, right? Like, do I want to apply names to faces? Do I want to classify transactions as fraud? And then they need the data that correlates with those decisions, right? And if they don't have either of those, if they're confused strategically, they can't do, they're not going to succeed with deep learning. If they don't have the data that correlates with those decisions, they're not going to succeed with deep learning. And I'm telling you this because this is, if you're going to deploy deep learning to production, you have to convince companies to do it first, and they have to meet those preconditions before you're going to produce value for them. So, as you probably know, deep learning can also be called machine perception. So it's classification, clustering, making predictions about almost any data type, images and video, sound and voice, text and time series. And that has all kinds of crazy applications, from fraud and anomaly detection. So transactions are simply time series, drug discovery, predictive analytics like predictive maintenance, predicting breakdowns, churn prevention on customers, using weblogs to predict when they'll leave, market forecasting, so predicting demand so that you can tell your factories how much to produce, and things like image recognition or voice recognition. So basically, it's machine perception. It's machine perception, broadly speaking. And I guess the reason why I'm speaking here tonight, the reason why you're probably listening here tonight, is because deep learning happens to be the state of the art. Among all the AI algorithms out there, deep learning is setting records year after year in some very important problem sets, right? And we are achieving accuracy in the high 90s, right? So 95% up to 99 point something percent, right? And sometimes that's better than humans perform, right? And when that's the case, when algorithms do better than humans, you don't need to make excuses for your algorithms anymore, right? And businesses face a radically different choice, because they used to have a bunch of humans who cost a lot of money to filter through data and make decisions about data, and they were using those humans because they performed better than the algorithms. All of a sudden, the algorithms are performing better than humans, and they're infinitely replicable, right? So what's the trend here? Deep learning and AI in general is lowering the cost of thinking, right? And it will continue to lower the cost of thinking for a lot of white-collar professions and people involved in this kind of data analysis and classification. So like, if you want to talk about an AI stack, right, the place where AI happens, this is one way to think about that context, right? So you get a data source, you gather your data from somewhere, right? Like, what do companies do with data? They gather it, they move it, and they store it. So they're going to gather it from weblogs or the Internet of Things, right, or from some legacy database. They're going to get it out of there, move it through these pipes. They could be Kafka or Swarm or Flink, right? Dump it into a data lake like HDFS, and from there it can be fed into this decision-making layer, right? So To get it from HDFS to there, you're going to do a bunch of different things with it. You're going to normalize it, standardize it, clean it, shuffle the columns, do some search and replace, and then present it to a neural net as a vector or a column of numbers, which are the things that neural nets understand. Now, once you get into this place where you're feeding data to a neural net and training it, it's important to think about a couple things. The main thing to think about is how long will training take, right? And do I have the right software and hardware to get through training in a reasonable amount of time? Now, some people when they're exploring data or working with small data sets don't have to worry about that, right? And the tools you're using may already be perfectly sufficient for those purposes. However, when you move into deploying deep learning to production, you're often going to be working with much higher volumes of data. Those much higher volumes of data present new problems, especially in the time it takes to train neural networks. So you want to be able to do that fast. So before I talk about too much about the time it takes, I want to talk to you about kind of the deep learning market, the kinds of companies that we run into. This may match the taxonomy of your clients, the people you're already talking about machine and deep learning with. So we think of it as a pyramid. What does that mean? At the peak, you have a few companies. At the base, you have a ton, and in the middle, it's an increasing number. So at the very top, you have maybe a half a dozen companies that are building their own deep learning frameworks, right? So let's talk about the main frameworks that we built. TensorFlow is number one. It's built by Google. Caffe is number two. It's built by AmpLab at Berkeley, right? Torch is supported by NYU and Facebook. CNTK is supported by Microsoft. Amazon has adopted something called MXNet, as you may know, and Baidu produced something called Paddle. So those few companies produce their own deep learning frameworks, and it's highly unlikely that deep learning specialists like us, and maybe like you, will ever sell deep learning solutions to them, right? Because they're already boarding a lot of the deep learning talent in the world. But if you go down one step, to the companies for whom it's not efficient to build their own deep learning framework, right? Suddenly you have potential customers as a deep learning consultant, right? Which is one of the things we happen to do. So what are these companies, right? They have teams of quantitative analysts, which usually include French mathematicians, because your country produces so many wonderful mathematicians. So they have teams of quants often they're on Wall Street, they're in large tech companies, they're in large e-commerce companies and telecoms, right? And they already know how to build algorithms if they want to. It's not going to be efficient for them to build a huge framework to maintain it. So they'll be the early adopters of other people's frameworks, whether it's TensorFlow, MXNet, or something like Deeplearning4j, right? The more problematic companies to work with, right? The ones that present more problems start here, right? So tier 3 companies, they usually adopt Hadoop. They have a big data strategy. They know how to gather, store, and move data, right? But they may not have invested enough in their core data team, right, to keep their versions up to date, right? So if you, as a deep learning practitioner building solutions for companies, run into archaic, obsolete versions of Hadoop, that's going to be a huge warning sign, right? And what that warning sign means is that a client like that is going to cost you a lot more time and effort. However, they usually have the basics, which means they have a lot of data. They're storing it on an open source stack. And then finally, tier 4 companies, largest number, they outsource their data management to other companies. And although many of them are interested in AI, they may want to talk to you about deep learning. They're not ready to work with you to build something together, right? So they come to us a lot, and we tell them to come back in a year or two. Oh wow, that didn't translate well, did it? Okay, so this is the reason why we built Deeplearning4j, right? Let's say the J is for the JVM, right? A lot of the big data ecosystem out there was written for the JVM. Hadoop is written in Java. Spark, last year's most popular Apache project, was written in Scala. All of these others are in Java or Scala, right? And so when you're writing a tool in the same language or on the same kind of virtual machine as these other tools, it makes integration a lot easier, right? So one of my arguments tonight will be that the JVM is actually is an interface that provides advantages, especially for distributed training when you're training neural networks. Now, how many of you here build deep learning stuff? How many of you here work with neural networks and train neural networks? I see a show of hands. Okay, great. So in our experience, the workflow is actually divided. We largely, let's not talk about R or MATLAB or other stuff. In the open source world, it's largely divided between JVM languages and Python. And Python is especially useful in the kind of data pipeline, say Pandas to TensorFlow phase, right? So these are the cats of our deep learning workflow. I hope you invisible barbells, that's the training phase. Anyway, so the real question is, how do you make Python and Java work together well, right? Because if you're working in Python already, you know that Python is a very powerful language, expressive language, great for prototyping, right? But it may not deploy or scale up as much as you want. And the answer for us, right, to get the work done in Python to that JVM stack, working with the Hadoop and Spark and Kafka, Elasticsearch, is to take any model from any of these libraries, move it into Keras. And are you familiar with Keras? Have you heard of it? Okay. Well, so Keras.io, I highly recommend it. It's a wonderful library. It's a layer of abstraction on top of Piano and TensorFlow, right? That adopted the API of Torch, right? That makes constructing neural network architectures really easy, right? Now, all of these libraries, Piano's in Python, Torch is in Lua, right? The rest are Python. You can port your models into Keras, and from there you can port all the work you've done from those into Deeplearning4j, which means that if you're comfortable with Python, you can do your prototyping in Python. You can take advantage of some of our integrations on the JVM, right, by porting to Keras. Now, let's talk about why you might want to do that. So I mentioned that speed is important. How many of you here are worried about speed? How many of you here run into speed roadblocks? You are, okay, when you're working with these tools. So you may have noticed that not all of the tools are quite as fast as they could be. TensorFlow has improved a lot over the last year, but it's still not especially fast on multi-GPUs. It's not especially fast on multi-GPUs, and my guess is that it never will be. And there are a couple important reasons for that. TensorFlow has been optimized to work very well on the Google Cloud, not necessarily everywhere else, right? Now, we know that inside Google, they have really fast deep learning, right? I mean, nobody doubts that. If Google is the top deep learning company in the world, they're not necessarily making that speed available to other people. If you look at the way that distributed training works, they're using something based on a 2013 paper called Disbelief, right? Disbelief was written by Joe, and Disbelief basically is a form of all reduce, right? Where you're taking a bunch of workers, you're passing parameters back to a master. In 2013, they were doing it synchronously, a bit of asynchronous improvements, but it's still not nearly fast enough. And what do I mean by not fast enough? So you may think you can solve your speed problems by simply moving to the cloud and throwing a bunch of GPUs at it, right? But guess what? The wrong software eats up GPUs really quickly, right? Back in the 80s, they used to say, what Intel giveth, Microsoft taketh away, right? These days, what NVIDIA giveth, TensorFlow taketh away, right? With the wrong software, your training will take too long. So Elliot Turner founded a startup called Alchemy API that he sold to IBM. And what he's tweeting about here is that he needed 96 GPUs for 144 hours and a grand total of $13,000 just to reproduce somebody else's paper. So if any of you here are engaged in original research, you will know that finding the right neural network architecture is an even more computationally intensive problem, right, than just reproducing somebody else's paper. So my suggestion is that more hardware shouldn't necessarily be the answer, and many of us don't have the money to make that the right answer. What could be the right answer? The right answer could be better software. Right? So just to go back to that list of companies, right? All of these companies are using a form of what we call all reduce. Now, all reduce expands the workers you have as you gather more data. So you may have a master and 2 workers, but as you throw more data at training your model, you may have a master and 20 workers or a master and 200 workers, right? And the more workers you add, the more problems you run into with this all reduce formula. There's one way around it at Microsoft. CNTK, they use something called one-bit SGD, one-bit stochastic gradient descent. I don't know if you've heard of it, but I will tell you that as part of CNTK, it's the only part that you can't use commercially, right? It's the only part with a non-commercial license. And that tells you how important it is for them, right? Yeah. So from our perspective, there are ways to speed this up. We're using a library called Aeron as a parameter server, and we're working on ways to make GPUs talk to each other in new ways and perform the reduce together before they reach the master in new ways, right? So what you'll find from Deeplearning4j is fairly quick improvements in speed. I'm not saying we're the fastest now, but we will be sharing these things, right, in a way that doesn't hold anything back. If you find with CNTK, we will be sharing them with you in a way that you can use them commercially, right? So you don't have to pay $13,000 to. I'm sorry, something's going on. What happened? It's I think I lost my picture.
Okay. Yeah, we were given something to push on it, and it looks like it's lost.
Yeah, okay. That's cool. That's cool. I can wait. Do you want to work on this and I'll just keep talking?
I'm going to find
we'll find somebody. Okay. Cool. Yeah. Let's see. So what else? What else can I tell you? So yeah, what I'm trying to say is that there are algorithmic solutions coming online to make training go a lot faster in a distributed way. They tend to use some of the distributed computing tools like Akka on the JVM, AKKA. How many of you have heard of that? Have you heard of Akka? Yeah. They'll be using Aeron, in this case for parameter server. They'll be using Scala in general. And Scala, as you may know, is a multi-paradigm language that was built for concurrency from the bottom up. Because given how expressive it is, it can mimic the Python experience, right? So one thing you'll find with Deeplearning4j is a Scala API, ScalaNet. It's Apache 2.0 and it's on GitHub. It gives you the Python experience, but it allows you to access the kind of massive distributed computing in a way that you might not be able to with TensorFlow. So with that, I think I should open this up for questions. Please tell me if I was unclear in any way. Yeah, hi. You know, I don't deal with MATLAB. We're just kind of purely open source, and we don't pay it a lot of thought. It's a powerful tool, sure, but the people who are using MATLAB are usually not the same people who are kind of going for the open source stuff.
Chris,
yeah.
You just restarted your computer.
This is for computer, and you should feel free to restart. And then we'll get the file. I didn't restart. No. Did you restart?
No.
It's got a minus.
Okay.
Yeah. Yeah, sure.
It's a bit long, open question.
Yeah.
Basically, I've been doing this for, I don't know, more than 20 years.
Yeah.
I'm not very good at the PhD. And
probably better than me. Yeah.
That what we're seeing now is basically the advantages of huge hardware things 20 years ago. Algorithms for deep learning, there are more levels of neural nets, okay?
Yeah.
But basically, to build a huge amount of CPU power, so you're saying it's not going to be solved by hardware. But maybe yes, it will be solved by hardware. Forget another 10 years.
Okay, no, that's a great question. The thing with optimization is that you only have to be wrong once, and you lose all your gains, right? So hardware capacity is increasing, right? And hardware capacity is what makes our advances in deep learning possible, right? Like we're at a moment now, a confluence of more powerful hardware and bigger data and better algorithms, right? Those three things together are the reason why anybody's talking about deep learning, because the algorithms old, as you know, right? Like they've been around a long time. So I think Fukushima was doing neocognitrons in 1979. Neural nets were huge in the early 80s, right? But they
McKenna was doing ConvNet basically.
in the early 90s, yeah,
Exactly.
sure, and the hardware wasn't there, right? So it's true that on one level, AI is advancing hand in hand with hardware. The more powerful the hardware is, the more we're going to be able to do with it. But we can sacrifice the gains of the hardware by building bad software. Yeah, I don't know. Does that answer your question?
I don't know what about the Intel stuff. They're not want to do the
Yeah. Okay. So Intel. So the question is are Intel's moves in the deep learning space going to change anything? Here's the background on Intel. Last summer, Intel bought a startup called Nirvana Systems, and Nirvana does two things. They build deep ASICs for deep learning, and they built an open source deep learning library called Neon. Now Neon has been one of the fastest deep learning libraries publicly available. I'm not saying it's the fastest in the world, because that's probably in some nation states military, right? But Neon is one of the fastest publicly available deep learning libraries. Neon really only did a couple types of content. If you remember, it was never a general purpose deep learning library, right? It was focused on image processing above all, but it did it really quickly, right? Now, Intel says that it's bringing Nirvana's chips, which have never been made, right, into production in 2017. I think it's going to be, in 2017. I think it'll be late 2017, which may mean 2018, right? Like these hardware things take a while to bring out. But Intel is trying to come out with an answer to GPUs. That's true, right? They've made many other attempts to answer GPUs in the past, and that hasn't worked, right? If they do this thing with Nirvana, I suspect they'll have a GPU that's really good at one kind of deep learning algorithm, probably convex, right? Because the nature, like when you bake something onto silicon, it's better not to bake something general purpose if you want to make it really fast, right? You want to bake a specific type of algorithm onto that silicon, right? Like when they program FPGAs for deep learning, they program them for specific algorithms, right? That people have decided they need to use in high frequency trading or something like that. So I think what we'll get from Intel are chips that specialize in a particular, let's say, vertical or solution, which will be image processing. Does that answer your question? Yeah, it's speculation, right? Like I don't have inside information on them, but I know some of the people over there, and I've kind of watched it for the last couple of years. So that's what I think will happen.
Yeah, we're still trying to get back to life. Okay. We're waiting for someone to hear from them.
Yeah. I'm comfortable with this. It looks like there's some more questions.
Okay.
From the audience. Yeah.
Sure then.
So you mentioned IBM Deeplearning Watson.
What? So Watson. So Watson is a line of business at IBM. It's not a technology. It's actually a group of many different technologies. One of which is Deeplearning4j, right? But also many others. And I would say so Watson came out of kind of a game show appearance where Watson the technology won with a question answer system. Right? Now they've expanded it to image recognition and healthcare diagnostics and all that other stuff. Many people at Watson are still using other types of algorithms like support vector machines in their last year's paper.
And the part of the variable is important.
It's hard for me to speak to that. Yeah, I mean, the teams that are using Deeplearning4j are the absolute best. Yeah.
So, you what the Spark and Hadoop, but is it possible to imagine deep learning GPUs?
Well, yeah, sure. Oh, am I too close to the mic?
No, it's like
Oh yeah. Okay. Yeah. So you have a lot of time, or you have a lot of hardware. Yeah. Right. So some people have learned to be resigned to the time it takes to train neural networks on hundreds of CPUs. Right. And we work with teams that don't have control over their hardware stack, and that do clusters and hundreds of CPUs to parallel, right? And they train neural nets with them. Right? So yeah, you can do it without GPUs. You can. And beyond that, if you want to get into kind of more exotic hardware, there's a lot of things besides GPUs that you can use, right? So there are ASICs, there are FPGAs, right? A lot of the high frequency trading firms are using those field programmable capabilities. Just tailoring those to specific algorithms. Is that it?
So the things are if you don't have GPU.
The answer is, yeah, the real question is, how patient are you? What's your patience threshold, right? Like, here's the real situation is, neural networks, everybody experiments to find the right architecture for a neural network, right, that fits data, so that neural network can learn on the data. So every time you change your hyperparameters, you have to initiate another training and see how it works, right? So if you have to wait 2 weeks, right, every time, then yeah, obviously that's too slow. And then on a meta level, most teams are not, fiddling with their hyperparameters themselves anymore, right? They're running through the search space of all hyperparameters, right? Which is even more computation. Yeah, so the great advantage, if you're in research and you're not using GPUs, then you are at a disadvantage, right? Vis-a-vis the large corporate teams, right, at Google and elsewhere, and all the hardware they produce. And I'm sure that one of the reasons why DeepMind even allowed itself to be bought by Google in 2014 was because it was just an all-you-can-eat buffet, right, of hardware. So thanks, Google. Yeah, cool. I can keep on answering questions. Actually. So yes, sir.
Has there been a benchmark to measure the speed of something like that?
On deep learning tasks? Yeah, sure. There are several benchmarks. So we have some internal benchmarks. We're waiting for the added credibility of the third party to do it, but we're approximately as fast as Cafe on non-trivial image processing tasks on multi-GPUs. Yeah, so if you're looking for a third party, there's a guy named Sumit Chintala at Facebook who kind of keeps the source of truth benchmarks for many different deep learning libraries. Sumit Chintala.
Another question is about data visualization. Which tools versus using data visualization?
Data visualization. I don't know what kind of data visualization do you want to do.
Visualization data. Obviously, we have to visualize the data.
Yeah.
So let's say face.
Yeah. Yeah, it depends on your language. Python has a bunch of amazing tools like Matplotlib, for example. Yeah. Like if you were working in Python Universe, I'd go with that.
So I understand that deep learning performs pretty well in certain kind of tasks, like image processing. But I would imagine that companies that they have some other type of processing or prediction tools that they might work well with what's possible in learning companies. Or what you're like, how do you add value by using learning to because it can bring additional accuracy, but at the cost of additional time to train for
Yeah, okay, yeah, sure. So I mentioned some use cases earlier that you probably saw, right? Like if any classification or clustering of predictive paths is susceptible to being tackled with a deep learning algorithm, right? And as you've probably seen, a lot of them over the last couple of years, just ranging from machine translation to machine transcription, right, are showing enormous gains when you apply deep learning to. Yeah. So moving from there, obviously companies are still working on all their old hard analytics problems, right? So recommender systems, fraud detection, that kind of thing. If you remember the Netflix prize a couple of years ago, Jeff Hinton and his gang won that $1 million prize with restricted bolting machine. So it's one of deep learning, right? For a media recommender system. So yeah, like you can apply it all over the place. I don't for companies. For enterprise companies, they're usually not going to say, oh, we're going to sacrifice a 15% gain in accuracy because it's just going to take 2 months to train a neural. Like that's not really the trade-off. They don't care that much. Obviously, they want it to go as fast as possible. They're not going to give up on a solution just because it takes a long time to train. In my experience. That's your
Let us do the second question, industrial question. So what you say to them, you tell them, okay, we need to budget the training costs and then budget it constantly. level, I would say, what's you actually tell them when you mentioned say about the amount of work and hardware and costs?
Yeah.
You talked to trade. What can you explain the distance here, the narrative here, you go to see?
Yeah. Okay. Like as with most, we work mostly on premise, right? And so as with most kind of on-premise solutions, the answer is usually it depends, right? Like it's not standard. Like there's so many different variations. If you were talking about deep learning as a service, you could quote some kind of standard prices for the whole market. You say, look, training, we know the Azure stack well ahead of time. We know how long it takes to train a certain net. Here's what the price is going to be, right? Companies usually aren't thinking in quite those terms when they've got their own Hadoop cluster, right? Especially if it's a Hadoop cluster they're kind of unhappy with already and maybe not seeing as much use as they want, right? So there's a lot of companies out there that have made enormous investments in something like a Hadoop cluster. They're actually waiting for something like deep learning to redeem that investment, right? Because storage alone has not been enough, right? So there's a bunch of there are a lot of middle managers in very large corporations who are kind of sitting on something that can either tank their career, right, or help relaunch it, depending on the success of this thing. So that stagnant hardware, may cost of using that stagnant hardware may not be prohibitive. Yeah, I don't know. I'm not sure if I answered your question. Nobody's ever kind of fault at just the fact that we need to train neural networks. They do occasionally bulk, but we usually just go with the hardware they have, or they do bulk is if we suggest that they buy a lot more GPUs, right, to get things done. Right, so they seem to be preferring the delay.
So you come, okay, if you've done it for them and say it's for protection, the Russians come back in, okay, the Russians will come to them, but and scam them. So you have to retrain, etc. Are they aware of it?
Are they aware that they have to retrain? Yes, they are aware that they have to retrain.
So it's a running cost for them. They agree that
It's a periodic cost, a recurrent cost. Depending on how often they want to retrain. Right? Like you can do online learning, right? You can decide if you want to retrain it every hour or every day or so I guess what I'm trying to say is if you are depending on what their thresholds or what their tolerance is.
What radical new features can we expect in the next 20 years?
Radical new features from us or just in general in the AI universe? Oh yeah, I mean, sorry, I don't think 2 years. I'll tell you what we can get to in 2 weeks.
in a sense, during 0.7, this construction has GPU support for paragraphs.
Yeah.
Is it in there? I didn't see the release notes.
Oh man, you got me. I don't know. I have to check our release notes. I think so. Are you on our Gitter channel?
Yes.
Okay. You know Raver 119?
Yes.
Okay. He's the guy.
Okay.
If he built it, it's there.
Okay.
Yeah. So what's coming up? All right. Who knows? In the next 2 years, who knows what's going to happen, right? Because quantum computing may actually work something, and that's going to blow everything else out of the water. If you want to think about the future of AI and where we like to take it, deep learning is most powerful when it's combined with other algorithms, right? So when you think about AlphaGo, for example, they combine convolutional networks with Monte Carlo tree search reinforcement learning, right? So solutions that combine several branches of AI are the future, right? Maybe so cool. And so we already have some reinforcement learning algorithms, and we'll continue to add cool new ones, right, to allow people to mix them. Yes, sir.
So you mentioned that some factories of the chips were catering for deep learning.
Yeah.
But the question is Spark or Hadoop can do they also adapt and tailor to deep learning algorithms?
Oh, our Spark and Hadoop tailored to deep learning algorithms.
I guess some people trying to tailor this kind of components of the whole system.
I mean, yeah.
I thought you were interacting with them to change them.
It's a question of how you use it.
So the question is, are there
out there for people working on replacing Spark already, but with more useful for the
There's people working on all kinds of stuff. Like, and I don't mean that as a joke. I mean, like, Apache Flink, for example, is much better than Spark at real-time streaming, right? So if you want to hook up real-time streaming to deep learning, maybe you would go with Flink, right? But I would like to repeat, because you can use Spark intelligently for deep learning, and you can use it really wrongly, right? And so Spark is not a good computation, right? It's a good executor. It orchestrates multiple host threads well. It's good for fast PTL. But if we could have avoided building NumPy for the JVM, we would have, right? We didn't want to have to build them, right? But we did have to build a tensor library that handled n-dimensional arrays that kind of bypass the overhead of the Java native interface, get down to C++ using Java CPP, because there wasn't a better alternative, right? So Spark does not give you doesn't present a good solution for large scale computation. So the best way to do it is just use it as fast as you can. But I want to say, like, Spark 40, how can I say, there's a separation of concerns, right? So, like, maybe Spark's as good as it's going to get for deep learning. Maybe it's not destined to be a deep learning tool, right? Maybe deep learning will happen elsewhere. We just use Spark where it's useful. Yeah.
This distribution of data that is more suitable for deep learning, there are other applications that can be better than deep learning.
Are there some algorithms that are better than deep learning? Yeah, that's a good question. Sure. Look, you do face trade-offs. So somebody over here mentioned the speed trade-off. Deep learning, how can I say? Deep learning is not the most, or I should say, deep artificial neural networks are not the most interpretable algorithms, right? So they don't have enormous explanatory power. That's changing. But if you need explanatory power, if you're building, for example, a credit risk engine for a bank, and that bank needs to tell regulators why it denied somebody a loan, right? Deep learning may not be the best algorithm to choose, because it's going to be hard to explain why you denied somebody that loan, right? If you use something like a random forest, right? With a random forest, you have a human transferring their knowledge to the algorithm, telling them they're a feature engineer, they're telling them what features to look for and how to make those decisions, right? Then, because the human tells the algorithm a story, the algorithm can tell a story back. That algorithm and that story can be passed on forever. You're not going to get that with deep learning, right? It's machine readable, but a lot of times it's not.
I think that's a stupid question.
Yeah, there are.
Yeah, trust me, they are. Deep learning is generally good for data that is overlapping itself. That is image, for instance.
Yeah.
The pixel is pixel, but essentially most of the pixels around it are kind of redundant information. So you need to have a lot of images to figure out exactly what the structure of images are with different layers and so forth. Has it been your experience that deep learning has been useful in other areas where somehow there was not a picture-like type of data? That is, you had data that were essentially not translatable into something like a picture, where it was doing well. Is that a stupid question?
I don't think it's a question. No, so I guess you're suggesting that all the work that they've done in sound and voice recognition is essentially an image-based.
Pretty much, yeah. Especially
because
in
they're
voice.
spec programs, yeah.
Yeah, I mean, that's one of the things they do. They are actually doing something else now. But one of the first things they did was actually put it in pictures and essentially to do exactly what you were doing for images.
Yeah.
But I'm more like on the side of other applications, like banks and so forth,
sure.
where the data is much more heterogeneous. It's somehow not an overlapping of instances and so forth. Has it been your experience with different customers, whoever that might be, that deep learning has been actually useful for
other areas than people that were using specifically for images and related to that.
I mean, like we call it deep because the depth suggests a feature hierarchy.
Yes.
Right? And feature hierarchies are just as useful applied to structured data,
yes,
like transactions, as they are to unstructured data,
right,
like images, right? And another kind of depth you can think about is the depth that comes with LSTMs over many time steps, which identify latent patterns over time, right? Where each transaction is one time step, right?
Yes.
And so, have we found deep learning to be useful there in classifying fraud? Yes.
Yes.
Yeah.
Okay.
Yep. It's I don't want to say equally powerful, but it's quite useful applied to structured data.
I see. Yeah. And so that's for anomaly detection in transactions. But have there been other areas where it's been used?
Yeah. Well, so you can it's not just anomaly detection in kind of unsupervised scenarios, but it can be supervised, right? Where you're every company in the world that's ever lost a client probably knows all the clients it's lost, right? And that means they have a labeled data set that they can train algorithms on to predict churn, right? And that would be just exposing algorithms to the web log, to the customer activity. And that can be a supervised learning problem, and deep learning is very useful.
What I'm trying to get at, all the business people or people related to business, understanding the hierarchy that comes out of the deep learning architectures that you find using the data, are they making sense to them? That is, it makes sense to the people doing images when you go for the hierarchy that you see structures that are more and more global somehow, and details in some fashion. Do those hierarchies in other type of data actually make sense to the business, to the business intention?
When you say make sense, do you mean do they offer a value proposition, or do the business people understand?
Do the business people understand the features that are coming out of the different layers of deep learning type of?
No, they don't understand. Neither do we half the time.
Okay.
Right? So no. I mean, we understand the math and we can see the results.
Right.
Right. And we can test the algorithms against a test set to make sure that they haven't overfitted. Right. But I mean, in most of these cases where you have a net with many layers, nobody understands the feature hierarchy very well. Right. Like there are. You may have heard there are attempts to give deep learning greater explanatory power. There's something called LIME, LIME, which you may have heard of. It creates heat maps over images, show people why the classifying images in such and such a way.
We're asking one of the guys that should show us.
Yeah. So deep learning will become much more interpretable, and that will give the business people an explanation, right, of why elements are deciding a certain way. But for the moment, we're not 100%.
I guess my next point is, since this explainability is like a huge issue, not just in deep learning, but also in machine learning. Since LIME came up, like KDB recently, do you guys have in mind to actually put one of those engine on the side that can help the business, the BI people, make sense of those layers and so on?
We're adding interpretability.
Okay.
So to answer this gentleman's question, interpretability will be one of the features we have.
And it's going to be LIME?
LIME, there are several tools, and LIME will be one.
Okay, great. And when is the timeline for it?
Q1 next year.
Q1 next year, 2017. Okay. I didn't want to push it. That's a good one. Okay.
Yeah. Any other questions?
So the beginning that the business people don't have decision, they cannot, they don't know about that they don't have hypothesis, then you cannot tell them. Can you assist them? Because the technology, how much is effective?
I think I misspoke actually. If a company doesn't know what decisions matter to it, then what you really need to do is go in and do what we call problem discovery. Right? The problem discovery, for example, they may want to automate business processes. Right? They may just have some highly complicated stack of procedures, some steps involving perception or data filtering in some way, and others not. Right? So in that case, you need to go into the teams, you need to figure out how the business processes are being performed, and then suggest to the company, this is your deep learning. Here's where we can save you money or increase your value. Right? And if it's a really big company, they'll pay for that. And if it's not, then you have to convince them with free problem discovery that you can be useful. Yeah.
So do you have many examples of, I would say, industrial, but not using data, which could be formed like I mean, I have in mind, for example, someone told me that ArcelorMittal has needed deep learning at some point.
Yeah.
And it's not natural because we don't see it as just a company primarily dealing with the data, right?
Yeah.
So my question is, do you have other, in your experience, other examples of hardcore industrial companies not related to data?
Yeah. So you're asking, what are some big companies using deep learning?
Yeah, but which are not really working on data. Google is working on data.
Yeah. No, I get it. At least outside of the usual suspects. Yeah, sure. Look, I mean, almost every major car maker is working on self-driving cars, which involves machine vision, right? And most major manufacturers are using machine vision as well as other other forms of anomaly detection to recognize what's leading to bad parts or good parts coming off the line. Right now, those same car makers are not just implementing machine vision, but they're beginning to think of themselves as software companies. You may know GM hired 4,000 developers over the last couple of years. Whether they know deep learning or not is another question. But they're beginning to think of the cars as rolling recommender systems, right? Like rolling Netflix suggestion boxes or burrito restaurant suggestion boxes, right? And that's a machine. That's a problem that machine learning can help them solve. And so some major ones in Asia, North America, and Europe are using deep learning to solve that. Let's see. Where we see early adoption, and so it's a paradoxical situation. Deep learning is an early stage technology, which means that as a startup selling this technology, we run into a lot of people who aren't ready for it. Right? That said, deep learning is also moving very fast. It's getting a lot of attention, and when companies think about their product roadmap or their IT strategies, many of them want machine learning components of some sort. So early stage is moving very fast, which is the situation. The companies that are actually ready to do something with it are usually native fits, right? Like they conceive of themselves as information processing companies, not necessarily the high-tech companies, but financial services, it's telecoms, it's e-commerce. That's where we see the most movement.
When you speak of smart
Yep, sure. Manufacturers, yeah. They're getting smarter with their factories, and they're also producing smart appliances which require the powers of machine perception in some cases, just like Amazon has.
Let me add something to this. I don't know if you recall, there was a meetup last year. I think it was over at Computer. It was a company. There you had Eloise Nunn, who's now the head of the SNCF data team, who was before she was working for a company. They were doing a POC for that proof of concept thing, and so SNCF has very large database of things they have never been used to a certain extent. So it's a bit like these other companies called that will come back to me. But for SNCF, for instance, they had codes of how wagons and trains were essentially failing. They had different codes of how the failures was going on. She applied a bit of autoencoders, so it's not really different yet. But she could actually figure out things that you could not figure out by just looking at numbers or trying to do regressions in the surface. So to a certain extent, I think deep learning is telling us if you have enough data that you're going to find things that you cannot find otherwise. But you have to have enough data. A lot of the companies you're referring to, I think have a lot of data, but they don't use it. It's like in the coffer somewhere, or even in coffin somewhere. But definitely, they have a lot of data. It's very well think of it. I mean, they know everything about it, except they're not using it efficiently. And what I advise some of these companies to do, and I'm not in that business, but when they come and ask me those things, I'm asking them to go to the people here in Paris, like Company Free and so forth, other companies, do a talk with them for like 3 months to figure out exactly if there is something that can essentially be gotten out of this data. That's the first step. And then the next step, you see that everything comes together after a while. If it doesn't work out, well, you know, at least you learn that it's not really, or you learn how to get better data from now on. And that's a different way of getting your business in the right way. So, but we also went to this other company. The very first meetup we had in September was at Banquier. They have lots of data, lots of them. It's labeled all over the place. They are putting up right now a science team that essentially is going to be looking at it so that we can do better recommendation system. So far, it has not been doing a recommendation system. If you know anybody that uses the system, you know that now the information is in overload for every customer. So they are now getting into the data science team that can do recommendation. But the thing of it is, they can do that because they have all these data, a lot of it. So I'm not quite sure I'm answering your question here, but there is this other thing that comes about that says that a lot of those companies that industrial companies are getting to be using photos and videos nowadays more. Well, that's directly a deep learning type of task. So even though they probably may not have that many of them, they probably have that many of them for a certain type of things they really want to look at. So it really doesn't take them 15 years to get that much data. A year, 6 months for some operations might be enough for them to figure out if there is something to do and getting out of that. Did I answer your question?
To get back to your earlier question, I think it was about GPUs, right? You can be clever about the problems you want to try to solve for people. So like some data types are just much lighter weight, right? So you might have better luck finding an LSTM time series data. Right? You could actually get a lot more work done if you're throwing images at a bunch of CPUs, for example. You have that. Cool. That's my topic. So there are no more questions. I guess we can wrap this up.
Are there any other questions for Chris?
Yeah, it's just small comments. Take what you just say there. We talked about video and images, but then thinking is natural language processing, and it's like when you think about it, it's like the thinking language, and it's we need online content. This is technically right now, and so because if you think that you are doing mistakes and then you a lot of some industry using text.
I think the issue with NLP so far is really that some of the deep learning models are not doing as well as state-of-the-art other techniques. But I think it's just a question of time. You know, it's just really
about machine station that was just in the state just swap to deep learning.
Right.
And that's
significant gains. Yeah, I mean, there are some things you can do really well in NLP translation, and there are other things with chatbots where the solution is technical system there. And that is because plasticity of language means that we need much larger, more complex models. Yeah, there's much larger models require a lot more memory, a lot more processing.
How much commoditization we're going to see, because we've seen IBM come in with its Watson suite, which is a brand, okay, but it's still going to be some products which are going to be phenomenal, right?
Yeah.
Microsoft is also creating a suite, which basically is very easy to deploy. Yeah. At what point is it going to break and put up and say, okay, it's easier for us to go straight to the deployed solutions from one of these 2 or 3 vendors and try to sort of put something together in how to all the maintenance of data piping issues, creating the pipes, to pipe things back and forth and run it for the appropriate amount.
That's a really good question, and it depends on the data use case, right? So if you trained neural nets before, you know that the first couple layers of weights are the most important, right? And with that, and that your data format will determine those weights in the first couple layers. So something like Watson or something, the kind of ready-made solutions that you're talking about, depend on data being in a certain format, right? But a lot of enterprises have custom formats, right? That their data comes in, so they're not ready. They're not ready to kind of adopt the cookie cutter solution from these large companies. Secondly, the services you mentioned are mostly kind of machine learning as a service, as a web hosted service, right? Where somebody else is kind of trained the model that they don't share with you, but which is on a server somewhere else. And you send your data in and you get the decisions back out, right? There's a major problem with that, in particular in enterprise, right? Because enterprise has very large data sets, and very large data sets by definition have their own gravity, right? It's costly to move that data, right? So the last thing that we want to do is have to send all that data to somebody else's model, right? And wait to get the decisions back up. And firstly, secondly, they don't want that service provider to own the metadata related to the data, right? They don't want somebody else to get smart and offer that model to everybody else, right? They consider that their proprietary. So, although I agree with you that deep machine learning will be commoditized in many ways, I don't think that those kinds of cloud APIs that I think you're referring to are the way forward for really large companies. I think they will continue to build their own custom solutions. So one of the ways that they might be commodified is through pre-trained models, right? Where with transfer learning, for example, you can just train on a ton of images and then give this neural network, this neural network model is 90% trained to someone else, and they can refine the last couple layers to categorize the types of images they care about, right? So that's a classic case of transfer learning and advanced commoditizes deep learning in the sense that people don't need to know as much about hyperparameters, right? They can just kind of plug something in as a component. So the people who cafe it all, has a model too, Torch has a model too. So a lot of people are offering these pre-trained models where you can kind of skip a lot of the data science steps, right? Just plug something into a web product. And I think there's a lot more of that coming on.
Yeah, it's really interesting because in the sense I intend that you're saying there is no stuff. So essentially, we've seen this with the databases, okay?
Yeah.
Companies have in-house database software. They don't do more. They may have their data in-house with a database engine pulled in from, I don't know, Oracle or whatever, or they run in IBM DB2 and IBM supplies the hardware and the software, etc. Yeah. And they can't stop the big vendors' solutions to be used into general and training and methodology. And in a sense, we see it here with Google. Google is sending out TensorFlow, okay? But at some point, some vendors are going to come in and basically take on the market, delivering this stuff directly to the customer, and basically bundle data warehousing solutions. What's going to happen here? How fast is it going to happen? Are they going to be faster there and you can do it yourself?
The TensorFlow bundle?
Not TensorFlow, but say Oracle or whoever sells actually is warehousing the data now. Are they not going to gain on you? Basically, the way you can't know that it's like seeing an expert.
They can try. They can try. I mean, one of the reasons why startups exist in Silicon Valley is so that big companies can outsource product development. That big companies aren't really good, right? So you could speculate that they'll be faster, but knowing them, I would say is probably more. It's just because internal politics gets in the way, and their kind of previous commitments to other products that they don't want to cannibalize constantly. So what I would suggest to you is that the real commoditization is in these open source frameworks like Deeplearning4j and TensorFlow, which are replacing the kind of DIY in-house algorithms that people have tried for a long
So I think people will be moving towards more maintainable code bases that where they have a lot of open source contributors.
You're just hoping to get post binary.
I'm being recorded, so why not?
Yeah, it's being recorded, so we can put it off.
Yeah, yeah. Blossom, what else, sorry? JBoss. Yeah. Yeah, okay, so we use OpenBloss. We use OpenBloss. I'm not sure. So this is a list of our open source libraries. If that's helpful. This is the neural net configuration layer. This is the ETL, so data preprocessing cleaning pipeline. If you know Tritactus Wrangler, this is basically Tritactus Wrangler, open source, right? Unplugged for Java, Cython for Java. This is our underlying C++ engine lib ND4J up there. This is the Scala API, and yeah, you see that we're using OpenBloss and OpenBloss as part of libnd4j. Now, libnd, what we do with that is we actually package it in a certain way. So we Dockerized it, right? We make it run on DCOS, that's the data center operating system, which is a layer of abstraction over Mesos, the resource manager, right? Which can kind of pull in as many GPUs, CPUs, and as much memory as you want when you're training these neural nets. So these are the parts, and that's the package of those parts, if that makes sense to you. We don't rely on JBoss anymore, or netlibloss. Those are out the door. Yeah. Yeah. If I can get that, if I can pull something up on this computer, which is not mine, I will show you an example of LSTM. And just showing you an implementation of an LSTM, we'll just be showing you Deeplearning4j, right? Deeplearning4j is a network configuration layer. If any of you go to our GitHub repos, right? So you go to github.com, Deeplearning4j, there's a repo called DL4j-examples. Right? You will find all our examples there, including several LSTM examples. I'm going to pull up one more. LSTM. What is there anything in particular you'd like to see? So this is the way we do things is we've got a builder pattern, right? Where you define the configuration of the neural network as a multi-layer configuration, and then you go through layer by layer, right? All the way through specifying the hyperparameters, which includes the loss function, the activation function, softmax, the number of nodes in, and the number of nodes out, right? So that's slightly different from the API you might encounter with Keras or Torch, but I think it's it quickly becomes self-explanatory. I hope it's actually easy to understand. If you're going to configure a neural network in Deeplearning4j, we would just use our own stack, right? So you'd be sending, you'd be doing your computation in ND4j and libnd4j, right? It wouldn't be working on TensorFlow, right? Yeah. So this is our Java API, but you can choose the Scala API as well. Those would be the two.
Yeah, let's put the data in the network, the network structure and network weights in the way that's used.
Yes. You can save and reload. You can save and reload models. Yeah. And and we have video tutorials.
So anything from the parents or folks with better models can be imported into
Anything that you can import into Keras, you can get through Keras Docs. So in Cafe and Torch essentially the availability. So there may be corner cases, like specific configurations that we can't handle, but most.
And what are the execution differences when you actually run it, or what we see in the differences? Because the American protection never run identically.
What do you mean?
Yeah, what you see, it's like if you compare running some additional learning, something like the better for one of the models.
Like
last layer, we use it, it's very popular now, transfer learning.
Yeah.
What do you see when you compare to the direct?
I don't know the answer. If you're asking about performance, like how much better do we do it or how fast do we go? I don't know. But we have our open source community is active on Gitter. Do you know Gitter? It's like IRC. Please ask that question. Our engineers are kind of there 24/7, so someone will do that.
So there's the GitHub and the GitHub.
Yeah, so GitHub is where the code repositories are. Gitter is where the conversation happens.
Okay. I don't know about it.
Yeah,
That's,
it's gitter.im/deeplearning4j /deeplearning4j.
okay, I just read this now.
Yeah, okay, yeah. And so like there's somebody there almost every hour, almost every hour.
For the express design the implementation we do it out using GNI execute using local OS plus all use like the MVCC. And you can regulate this amount.
Yeah. So you're familiar with Java, you know what a POM file is. And in the POM file, you can specify whether you're working you specify your hardware packet. So GPUs or CPU. Yeah. And so it's just one line of code. If you say I've got GPUs, it'll eat your GPUs.
All the computation is executed outside GPU.
Yeah.
Either on the
That's right. That's right. So we're just using the Java as the API and the JVM for the integrations, but all the computations have C++ keys. Yeah. And that's true for like every major deep learning library is basically has two languages, right? It has an API language, which is the community decides to serve, and the core language, which is where the computation happens. Everybody's got the core language of C++, and most languages which are Python are serving Java. Yeah. And accidentally do things like Hors.
And compared to Greece for like the pure algebra.
Yeah. Reese can't handle dimensional arrays. What's that? It can't handle n-dimensional arrays, right? And you need n-dimensional arrays when you're dealing with certain kinds of computational methods. So the reason why we built ND today was because Reese couldn't handle it. And so I'll just tell you the one weakness that ND4j has is that we can't handle sparse ranges. Right? So that's the one thing. If anybody here is looking for a project that we're looking for a contributor, we asked about upcoming features. We'll be adding sparse over the next year. So it's just a question of time and
is there another question for Chris?
Can you use some use case companies that use it or?
Yeah, sure.
I'm in France because Orange is a customer. And Orange uses us for fraud detection. Telecoms a different kind of fraud than banks. Obviously, it's not about credit card transactions. It's about the way people use their phones and let's avoid their calls.
So, I've already got you here to do the recommend the system for the
I can't talk about that.
The answer is no.
I can't talk about
The answer is no. And the answer is, what the hell are they waiting for? Okay. Thank you.
Right.
Another question for Chris. It's getting late, especially for just a 1 hour meetup. Well, thank you very much, Chris.
Yeah, thank you, everybody.